Welcome to Lesson 5 of Module 4. We're going to start off with our do now. So when we're designing practical investigations, how we make sure results are reliable, accurate, and valid. So pause the video now and write down a few notes. So the reason I wanted you to have a look at that in your do now is because, again, we're looking at what leads to the acceptance of scientific law. But in this lesson, we're going to be looking at designing and then collecting evidence to show that results can, in fact, be predicted by laws. And we're going to be looking at specifically Ohm's law and the law of conservation of energy. And in this, our learning intention is to perform an investigation to collect evidence to support an idea. So laws are useful in predicting future events or to explain the results of events. And predictions using these laws are important because future inferences can be drawn upon before any experimental data is collected. So hopefully the hypothesis and the predictions that scientists are making using these laws will be correct. So the mathematical equations used to express the statement of laws can allow computational models to be developed to create hypothetical scenarios and therefore allow us to solve real situations when they arise. So first we're going to be looking at Ohm's law. And Ohm's law is the idea that current, which we're going to look at as I, passing through a conductor or a resistor as R, is directly proportional to the potential difference or the voltage at a given temperature. So really we're looking at the relationship, in fact, between current and resistance. And current, just a reminder, is the flow of electrons around the circuit, and the resistance is the amount by which a circuit tries to stop the flow of electrons. And so we can see here that V equals I times R. So we can use Ohm's law here is an example of how we can make a prediction. So looking at the current on the x-axis and the potential difference or the voltage on the y-axis. And if we use the gradient here, we can predict the resistance of a light bulb with a voltage of 0.8 and a current of 0.45. So we can see here that applying the formula allows a particular point for us to calculate the difference here. And so this resistance formula here is just this one here. Okay, so if we want to find R using algebra, we find that V over I equals R, and we can see here that the predicted resistance would be 1.7 ohms. So we're going to pause this video now and watch a little bit more on Ohm's law before we complete our experiment. And the law of conservation of energy. So it's the total amount of energy in an isolated system remains constant. So the energy is never created nor destroyed, but in fact it is transformed within that system. So we're going to be looking at both these videos here. So on the left, we have just the law of conservation of energy. On the right, we're looking at a crash course in engineering. Okay, so just on the law of conservation itself. So the investigations we're going to undertake, so with Ohm's law, we're going to be setting up a circuit and see if we can use Ohm's law in the circuit that we create. And for the law of conservation of energy, we're going to be setting up our little roller coaster and seeing if we can, in fact, see and use it as a prediction for the law of conservation of energy using the practical investigations that are outlined in our booklet. And then finally, we're going to complete our Google form. Again, it's got some questions in there, this time using maths. So a reminder that all investigating science exams, you will need a calculator, just in case there are any graphs or calculations that you do need to perform. And then updating our inquiry question log with what leads to the acceptance of a scientific law.